Given question, design a DFA over the alphabet set A, B such that every string accepted must start and end with different symbol. So let's begin a solution. The step 1 is to define the language. Language will contain all possible valid string. So we'll first find out the smallest valid string possible in the language. The smallest valid strings can be A, B, starting with A and ending with B. That is, start and end with different symbol. Or I can have B, A, starting with B and ending with an A. Right? Or I can have A, B, 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 A, B, A, B, A, B, 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 and so on. So the language will follow the rule of starting with different symbol. If it is starting with A, it will end with B. If it is starting with B, it will end with A. Right? Solution. Step 2. Step 2 is to construct DFA. For that, I have to follow two rules. One is first construct DFA for the smallest valid string. Next, complete your DFA by responding to all the pending inputs at every state. Okay. So let's start. We'll first construct a DFA for the smallest valid string, starting from the initial state Q0. Okay. There are two smallest valid string. One is AB and other one is BA. So let's begin. We'll first construct the DFA for string AB. From Q0, if I get an A, I reach to Q1, and from Q1, if I get a B, I reach final state because this is a valid string. This is Q2. Right? Next, I have BA as well as another valid string, smallest valid string. So Q0 responded to A. Now at Q0, if I get a BA, if I get a B, I go to state Q3 and then A, I reach final state, that is Q4. Clear? So I have drawn the DFA for the smallest valid string. In this case, we have two smallest valid string, that is A, B and BA. So now let's complete our DFA by responding to all the pending inputs at every state. Q0 has responded to both A and B, it is complete. Coming over to Q1. To reach Q1 has responded to input B. Okay. To reach Q1, I have input A. That is, from the initial state, I have input A. Q1, at Q1, if I get an A, is it a valid string? No, it is not a valid string because I need to start and end with different symbol. So here, even if I have multiple A's, it is not valid and it should not reach final. So I put up a self loop of input A at Q1. Fine. Moving forward, Q1 has responded to both A and B. Now we have to check for state Q2. To reach Q2 from the initial state, I have input A and B. A and B. That is, from the initial state, this transition, and from Q1 this transition, right? At Q2, if I get an A, is it a valid string? No, it is not a valid string, right? So it should not reach final state. So I know that Q2's for at state Q2, the transition of A will not be to a final state. So I put up the transition of input A to state Q1, because after A, if I am getting a B, this makes the state string valid, right? And from Q1 I have this transition B back to final state Q2, right? So let's check this out. If I get an A in the beginning, at Q0 to Q1 for input A, and from at state Q1, if I get input B, I am reaching Q2. At state Q2, if I get an A, I am going to a non-final state Q1, fine. And from Q1, if I get B, I am reaching final, because this is a valid state, valid string. Clear? Now Q2 has to respond to input B. Once again, to reach Q2 from the initial state, I have this transition A and then B, right? If I get a B at state Q2, is it valid? Yes, it is valid, because I am starting with an A and ending with B, which are two different symbols. So even if I have multiple B's, this string is still valid. So I put up a self loop of B at state Q2. So this entire part completes up a case wherein I am starting with A and ending with B. Clear? So now let's proceed to the other case wherein I am starting with B and I should be ending with A. Coming to Q3, to reach Q3 from the initial state, I have to come across input B. Q3 has responded to input A, it has to respond to input B. If I get B at Q3, is it a valid string? No, it is not valid. If I have multiple B's, still it is not valid, because it is starting and ending with same symbol, that is B, and it should not reach final state. So I put up a self loop of B at Q3. Fine. So Q3 is complete, it has responded to both input A and B. Let's check for Q4 now. Complete the state Q4. To reach Q4 from the initial state, I have the transition Q0 to Q3 with input B and Q3 to Q4 with input A. Now if I get an A, is it a valid string? Yes, it is valid, because I am starting with B and ending with an A. Right? So even if I have multiple A's, it is still valid. So I put up a self loop of A over here. Fine. Let's check for input B. To reach Q4 from initial state, I have input B and A. Input B and A. Now if I get a B, now this is not a valid string in the language. This just doesn't justify our condition of starting and ending with different symbol. Here I am starting with B and also ending with B. So this is not a valid string and should not reach final state. Okay. If this string can be valid if I have a case like this, right, wherein after B I am having an A. So where shall I place the transition of input B from Q4? So if I put the transition of input B to state Q3, I am justifying this case like even after Q3, if I get an A, I am still reaching final state, that is Q4. Fine. So this handles the case of starting with B and ending with A. Fine. So this is how we construct a DFA for a given problem. So next step is to define 5 tuples of DFA. We know that DFA is defined by 5 tuples, that is Q, sigma, Q0, F and delta. Q is a set of finite states. So here we have states from Q0 to Q4 in our DFA, Q0, Q1, Q2, Q3 and Q4. In input alphabet set, we have A, B, initial state Q0, set of final states, here we have Q2 and Q4 as final state, delta, that is transition function which is given by Q cross sigma corresponding to Q. Step 4 is to construct up the transition table. Okay, so let's start. For input A and B, starting from Q0, Q1, Q2, Q3 and state Q4. Q0 is my initial state, Q2 is my final state and Q4 is my final state. So let's check the diagram. For input 0, state Q0 for input A, where does it go? It goes to state Q1. Q0 on input B goes to state Q3. Q1 on input B goes to Q1. Q1 on input B goes to Q2. Q2 is a final state, so let's mark it. Q2 on A goes to Q1. Q2 on B goes to, is a self loop, goes to Q2. Q3 on A. Q3 on A goes to Q4. Q3 on B goes to Q3. Q4 on A goes to Q4. And Q4 on B goes to Q3. So let's mark our final states here. Okay. Next step, step 5 is to give an example. Check the DFA for a valid and invalid string. For a valid and invalid string. Fine. So we'll take an example of a valid string. Here, if I am starting with B, I should be ending with an A, right? So now let's check. This is a valid string in the language. So let's check from state Q0. Q0 on input B. Q0 on input B goes to Q3. Next input is A. Q3 on input A. Q3 on input A goes to Q4. Next input is B. Q4 on input B. Q4 on input B goes to Q3. Okay, here Q4 is final. Right? Next input is an A. Q3 on A. Q3 on A. Q3 on A goes to state Q4, which is final. So at the end, we are reaching final state and the string is valid, so our DFA is correct. It is working for a valid string. Now let's check whether it rejects an invalid string. So let me take an example over here as ABBA, wherein I am starting with an A and also ending with an A, which is not allowed. Our machine should reject this string. That is, at the end I should be present in a non-final state. So let's start. Q0 on input A. Q0 on input A goes to state Q1. Q1 on input B. Q1 on input B goes to state Q2. Next input is B. Q2 on input B. Q2 for input B goes to state Q2. Last input is A. Q2 on A. Q2 on A will be in Q1 state, which is a non-final state. This indicates that the given string ABBA is rejected by a machine since it is not reaching final state. So this is how you mention all 5 steps and get full marks in your university exam.